Hello, today we will look into this paper called Pic2Word. Basically, this is based on the composed image retrieval. In this video, first we will look into what is composed image retrieval and then what's the main idea behind this paper called Pic2Word. So let's get started. For composed image retrieval is nothing but it's a composition of language and a text. For example, it's a simple retrieval. So if you know about image retrieval generally you give a query and you have to fetch the target images uh, which matches the query. For example, you typed dog and you wanted images of the dog. So that's a general image retrieval. The composed image retrieval, however, is the query is a combination of itself image and a text. For example, you can see here, I'm just zooming it out a bit. So your query could be something like a picture of a dog and then let's say not a description of the image, but let's say an additive text which is, let's say, inside a hole. So ultimately you want a dog inside a hole, and that's the target image that you ultimately want to retrieve. And the other example could be, let's say, this t-shirt which looks okay. I want this t-shirt with cream color, with a in cream color with a blue picture. So and the target image is similar to like this. For example, or other could be, let's say, a dog in a pool. So you want something uh, of a picture of a dog which is kind of which is playing in a pool, something of that sort. So what's the main idea of this? So once you have understood what is composed image retrieval, so if you look the history of the composed image retrieval, this was mostly trained using supervised setup and usually required a triplets of the positive pairs and the negative pairs. So what this paper has proposed actually is a very simple idea for this composed image retrieval, which we'll look now. Let's look each of these components. So it's very easy to summarize the main content of the paper. So it's mostly based on the clip based approaches, where you usually have this vision encoder and a text encoder. If you don't know about clip, just a quick synopsis. Clip is nothing but let's say a model trained on a visual language space using a vision encoder and a text encoder. So you pass an image through the vision encoder and the corresponding or the annotated text for the corresponding image with a text encoder, and you do the contrastive learning here. And the model trained is basically can be used to map any corresponding image to the text space and text space. And all these approaches are based on, or mostly the upcoming approaches in this composed image retrieval are based on this clip-based architecture. So what they have done, so usually similar to the clip, they have passed this image through the visual encoder and the corresponding text through the text encoder. The difference here is they have provide a learnable token S. So for example, let's say this is a photo of a cat. So what they do is say they provide this description of photo of S. S is a learnable token here, and this is basically passed through the text encoder, and these both are frozen. So just remember, these are taken from the clip encoder. So these are basically the clip based models, and then trained using the contrastive approaches. What's the idea? So here S is a mapping from this vision space. So you have a vision representation or visual representation of this of a cat, and you are trying to map using some kind of a learnable mapping function f to a token s. So for example, let's imagine all this these are all fixed and s is just a learnable token. So initially it starts with some random s which you pass through the text encoder, and you try to bring these closer. So what will happen is, since these descriptions are need to be closer in the space, the embedding of s will move towards the embedding of, or some kind of some representation of the cat in this embedding space. So that's the whole idea. So you want to have a learn this token, uh, and so that's, and let's look into how this is during the training part, what this will happen. So you have this learnable token, which is nothing but a mapping function, a mapped function from visual representation, a visual representation of a particular image to the embedding space of the text encoder, which is then passed through the text encoder to get the p, and v and p are basically contrastively aligned. So what happens during the inference phase? So for inference phase, you have this, let's say, a dog, which is basically passed through the visual encoder to get their visual representation v. Now, since we have learned a mapping function which will map this visual representation to the embedding space of the text encoder, we'll use this learned mapping function v to map it to the text embedding space of the text encoder. Now I'll got, okay, I got this s, which is basically correspond is to the dog in the embedding space. So what I'll get is a dog in a pool is a text query, is a, and you get the encoded is the textual representation of that dog in a pool. You pass it to the candidate images, and you map which candidate image representation is closer to the query feature representation, and you take these as the retrieved images. So yeah, so this is all that is there in this paper. So you can easily look, let's quickly go through this. So this is nothing but the image L2I and I2E is basically, so when you are optimizing this similarity, you would optimize both ways for, from I to T and T to I. And as usual, this is the contrastive representation for visual representation of image and the text pair. This is, sorry, I think this is a preliminary for the clip, how the clip is trained. So yeah, for yes, here it is how this model has been trained. So B is for vision representation, and PI is the text representation with the learnable token. And same similar to the clip, I2I and I2T is there, which is basically mapped. So nothing special here. And let's look into the results. They show yeah, the experiments on this domain composition. So where you have, let's say you want a fish, and you have an image of the fish and combined with the origami. So basically you want a fish in the form of origami. Similarly, tiger in the form of origami, and shark in the fish of I don't know if it is shark or not, but yeah, whatever, this fish in the form of a sculpture. And this is the retrieved images that you get. And for these are the zero shots. So basically there is no supervised training, you're just using this mapping function to learn, and these are the results on cartoon, origami, this kind of domain. So basically in cartoon you want the cartoon representation of the given image. Origami, you want the origami toy sculpture similar to what we discussed here. And these are the numbers that you can clearly show. Based on the other methods, they are well above the baseline numbers. even on the evaluation on Coco, which is basically what they've done is the object composition task. So they have this image of a kite. They want kite, chair, backpack, person, and wanting all this to be present in the particular image. They now want this is a mouse. They wanted a laptop and this mouse. Now the remote with this bed, this kind of a person and an airplane. So a composition task where you want to combine certain images with the query. So they have mentioned here. So what kind of task? The first is the domain conjure, as we discussed. So basically, image in the form, im- image in the form of, uh, let's say, a tiger in the form of a origami, some shark in the form of sculpture. So these are basically the domain conversion. So you're trying to convert the image from one domain to the other. Object and scene composition, where you want to combine multiple, for example, laptop and mouse. You want to combine multiple images in the target image that you want to retrieve. So yeah, similar to those, for example, iPad and MacBook. So you have given an image of an iPad and type the MacBook. So you wanted iPad and MacBook in the same image, something like that. Sentence specification. So the third type of task they have performed is sentence specification, where they say the modification of the reference image can be given by the sentence. So for example, you want to change something in a given image, and you want to retrieve the target example. Let's say you have a green shirt. You want a shirt with a blue color. So that's kind of the same shirt with a blue color. So basically, that's what he intends. So this is basically the sentence modification in the image itself. So for example, and the prompts that those kind of prompts then use this photo of dash text, where text denotes the modification part. Yeah, and these are the composed image retrieval task on the multiple uh, data sets, CIRR, Fashion-IQ, mm, and uh, and these are basically the well-known earlier supervised. Some of them are supervised methods, and these Pic2Word zero shot methods. Yeah, so this is one of the very simple paper. I still showed the very good results using this image clip based architecture. And yeah, do have a go through the paper and let me know if you have any questions on this. And some of the failure cases is they do not have the sketch mostly, so they are not able to kind of walk this architecture with the sketch images. uh, For example, here they say, okay, they want a real image of this lizard or real image of this, but they're still not getting a real image. So what they have sent is retrieving image from non-natural image domain is likely to be successful. Bottom two, while retrieving natural images from sketch is non-trivial. Top two. So what they're saying is, given let's say a sketch image or something, and you want a corresponding real image, it's a bit hard to get those, while image of the other domain is much simpler to get. For example, is getting a sculpture of fish, a tattoo of chameleon or something like that. Why they're saying that? Because the natural images in the training data sets are not described within domain. So when you say a dog, it generally tends to mean a dog in the natural environment. How does it look in a real image, kind of thing? But when you, let's say, have an image or a sketch or a sculpture of a dog, you specify, okay, this is the sculpture of a dog, this is a sketch of a dog, this is a cartoon of a dog, but you don't specify that domain information when for a natural looking or a real dog. So that's what they're saying. So natural images are not described with the domain word in a pre-training image data set, while the other domains are often described with the corresponding domain names, which makes it difficult for uh, and there are some quite good evaluation studies. Please do look through and let me know if you have any questions on this. Thank you. We'll meet another time with another paper. Thank you.